All right, class, so we're going to go through our day 3 lesson on angle relations. Remember, you need to watch this video before doing or before coming to class because we will spend class doing a bunch of different practice problems. So it's important that you know this vocabulary and how to maybe do some of these constructions, even how to set up doing some of these algebra problems. There's a bunch of algebra problems on the back of this page in which you'll need to know how to solve for a variable. Okay, so for today's lesson, it says I can solve for missing values given an angle relation. We're going to be talking about a bunch of different types of angle relationships, such as adjacent angles, linear pairs, vertical angles, complementary angles, supplementary angles, a lot of different terms here, which are going to help us prove and solve for missing variables. Okay, so first, little background knowledge here. It wants us to find 3 different ways to name an angle. Just like the first couple of days of class, it's super important when we're doing when we're working in geometry that we properly name things, whether it's a line segment or a line or a ray, all the way up to an angle. So we're going to find 3 different ways to name this angle. On this angle, we have a couple of rays here. We have ray EG and we have ray EM. G, E, and M are all points that fall on this angle, and we even have a number 1 down there in the corner. So the first way that we can write this is we can say we have angle 1. So now you'll actually see the symbol angle written in a couple of ways. One of them is it kind of looks like an inequality sign, looks like a less than sign. You might also see an angle written that looks like a less than sign, but there's also like this little arch through it. Both that are in geometry, both are saying angle. And so one way you can write this is angle 1. The other ways that I'm going to write this is by using the points, G, E, and M. Now, the order of the points is kind of important because the vertex of the angle has to go in the center. It doesn't matter if I start with G or M, I just need to write it with E in the center of it. So one example could be angle GEM, and the other angle naming could be MEG. So it doesn't necessarily matter which point I started with on my ray, but the vertex, where the actual angle is, has to be in the center. All right, so that's 3 different ways I can name my angle. Okay, so now very similar to copying a line segment, we're going to go ahead and copy a angle. Let me dig out my compass here. All right, so very similarly, I want to just start with a point. I'm going to name this point. Let's see, we have K, A, and H. Let's go ahead and name this point B. All right, I want to first find the distance from A to H in this example. So I'm going to go ahead and put the point of my compass right on my A. I'm going to measure it out to H, draw myself a nice little arc that goes through H. All right, going to do the exact same thing here, draw myself a little arc. So this is very similar to constructing a line segment, except for this is going to be a ray. So B is going to be the vertex of my angle. So I'm going to start here, and I'm just going to draw right through my next point. Let's call it D. All right, I want to do the exact same thing for my other ray here. I'm going to put the point back at my vertex A, and then I'm going to draw a nice little arc through K. Same exact thing here. And then now I don't really know where this ray is going to fall, so I got to make this arc a little bit bigger. All right, making that arc a little bit bigger. Sorry, I'm getting a little blurry because I'm moving my paper a little too much. All right, and then last thing I want to do is I want to find the distance between K and H. So I'm going to put my point of my compass on my point H, and I'm going to draw a nice little arc through K. This is going to tell me like the width of my angle. All right, so I'm going to put my point on D and draw through this arc. And where these 2 arcs intersect, that is where my second ray of my angle is going to go. So from B, I can draw right through my angle, and let's call this Z. All right, so now I can say that angle KAH is congruent to angle ZBD. All right, those 2 angles are exactly the same. They're congruent. All right, down here, I already filled in this vocab just so I can kind of make this video a little bit quicker. So it says angles are measured in degrees. Draw a picture of a right angle, an acute angle, and an obtuse angle, and then state the possible degrees for each. So if you want to pause this and jot this down, you can. I'm just going to go ahead and quickly explain some of these. So you guys all know right angles because you've probably dealt with triangles before. But a right angle is an angle that is exactly 90 degrees. They denote that by the little square in the corner of the angle here. So this just says angle 1 is equal to 90 degrees. An acute angle is something that is smaller than 90 degrees. So for example, in algebraic terms down here, we just have that angle 2 is less than 90 degrees, but it is also greater than 0 degrees. So any angle between 0 and 90 non-inclusive is going to be an acute angle. And then lastly, we have obtuse angles. Obtuse angles are larger than 90 degrees. So what this is saying is this is angle 3. We see that angle 3 is less than 180, so it's a little bit less than a straight line, but it has to be greater than 90 degrees. All right, guys, these are our vocabulary terms for the day. I already kind of introduced these, but this entire second page is a lot of algebra, and we need to know these vocab words so we can help solve for some missing variables. So we're going to be talking about adjacent angles. Adjacent angles are two angles that share the same ray. They share the same side. They're just a word for adjacent is like next to. So they're just two angles that are next to each other. A linear pair, those are two angles that are comprised up of a line. It doesn't necessarily have to be two angles. It could be more than two angles, but it is composed of 180 degrees, which is a line. Vertical angles are angles that are across from each other. So if you have like an X, I'm just going to draw a little diagram here. If I have like an X situation, like angles 1 and 2 would be vertical angles. Sorry, I'm trying to squeeze this in. I'm running into my wall. Angles 1 and 2 are vertical angles that are across from each other. Complementary angles, these are angles that add up to be 90 degrees. And then supplementary angles are angles that add up to be 180 degrees. So we're going to use these vocab terms to help us prove and solve the problems on the next page. All right, so first example, it says we want to find the measure of angle AOC for the following diagram. So we have AOC, so I'm looking for this angle right here. And then we can use a bunch of different terminology here in those vocab words in order to solve for this. So for example, these two angles, they make up a linear pair. They make up a linear pair because if you look, this is line AB. Both of these angles fall on line AB. All right, these are also adjacent angles. These are also adjacent angles because angle AOC shares the same ray as BOC. They're next to each other. This angle right here that we don't know yet is right next to the 112 degree angle. And then lastly, these are also supplementary angles, which means that they will add up to 180 degrees. So I'm going to use the knowledge of supplementary angles in order to solve for this. All right, so what I can say my justification is I know that the measure of angle, let me try to write a little bit larger here, measure of angle AOC plus the measure of angle BOC is going to equal 180 degrees. All right, I don't quite know the measure of angle AOC yet, but I do know the measure of angle AOB is 112 degrees. And then now I'm just solving. So like if you wanted to, you could rewrite this as an X. You don't have to, but that's how you're used to seeing it in algebraic terms. And then now, hopefully you guys know that you can just subtract by 112. And I know I can do this in my head. I just want to show you guys that do not be afraid to use a calculator for a simple calculation. We just want to make sure that we are correct. All right, so we're going to do 180 minus 112, and we get 68 degrees. So the measure of angle AOC, I'm going to write this over here in the column, measure of angle AOC is 68 degrees. All right, and we know that because they are supplementary angles. All right, next question right here. We have a lot of the exact same vocab terms here. These two angles, measure of angle AOB and COB, they are a linear pair. They are both on the same line. They are also adjacent angles because they share the same ray. They share the ray OB. And then they are also supplementary angles because they, once again, make up a line. So they make up 180 degrees. All right, so very similar. I'm going to draw a nice little line right here to separate my work. We have the measure of angle AOB plus the measure of angle COB, and we know that equals 180 degrees once again because they are a linear pair. All right, AOB is 2Z, right? The measure of AOB is 2Z. COB is 3Z minus 10, and I know that equals 180 degrees. All right, now I just have an algebra problem, so I want to go through, combine my like terms, and solve for Z. All right, 2Z plus 3Z is a 5Z. All right, and then now I have 2 steps left. I want to add 10 to both sides. I want to get rid of my addition and subtraction. And then lastly, I want to divide both sides by 5, and I get Z equals, what's 190 divided by 5? 38. So it's not 38 degrees, it is just 38. So like the question says find the value of Z. If this question was a little bit different and said find the measure of angle AOB, I wouldn't be done with 38. I would have to plug 38 in for Z to figure out what this angle measure is. But this question just simply says find Z. Z is 38, so we're all done with that one. All right, 2 questions left. We have a solve for X. This one looks really crazy here. And then we have another one over here where we're solving for X and Y. So let me just give myself some territory here to write down. I like to keep myself nice and organized. Okay, so there's a bunch of different angles going in here. So for example, we have angle PON, NOM, MOL, LOP. There's a lot of different angles, but if you notice, these angles make up a circle. Not a great circle drawn, but they make up a circle, which we know is 360 degrees. All right, so my justification for this one is going to be that this angle plus this angle plus this angle plus this angle is going to equal 360 degrees. So it's very similar to my example 2 up here, except for I just have more than 2 angles. All right, so my justification here, if we want to, we can go through and do all these measures of angles. So I can say angle PON plus angle NOM plus angle MOL plus angle LOP equals 360 degrees. Right, that is technically my justification. All of these angles added up, 1, 2, 3, 4, equals my 360 degrees. And then now let's plug in the information we know. We know that angle PON is 24x. Our next one is 82 minus 5x. Our next angle is 12x plus 56, 12x plus 56. And then our last angle is 129, and we know that equals 360 degrees. All right, we're just now going to start combining our like terms and then solving for my variable x here. All right, so we have 24x, we have a negative, let me put my camera up here, we have a negative 5x, we have a positive 12x, and those are all my x terms, 1, 2, 3 x terms, and oops. What did I do here? Sorry. Oh, sorry. I'm putting an x. What am I doing here? 24 minus 5 plus 12. There we go. We have 31 x's all together. All right, now I'm going to combine my constants, which I'll underline here just for simplicity. So we have 82, we have a positive 56, and we have a positive 129, which gives us 267. And we still know that equals 360. Once again, I just combined my x's and I combined my constants. All right, now I'm solving for x, so subtract 267, subtract 267. 360 minus 267 is 93. And we have 31x equals 93. Last step algebraically is divide both sides by 31. Divide that by 31, and we get a nice, pretty number of 3. And then I don't have to plug that in because it just simply says solve for x. So once again, if it was like solve for angle PON, I would furthermore have to plug 3 in for x to find that angle, but I don't have to. I'm all done there. All right, guys, we have one last example here. These examples are, I can use a lot of different things. First off, I'm going to use my definition of supplementary angles. And then I am going to use my definition of vertical angles. So we haven't talked about vertical angles yet. They're just going to be angles that are right next to each other. All right, so first thing I want to do is I'm going to go ahead and solve for this missing piece here. I know technically I don't have to do that, but it's going to help me out throughout the problem. So I know that this angle that I don't know, and I know that this angle 36, these are supplementary angles, so they're going to add up to 180 degrees, right? These are going to add to 180 degrees. So I can simply find this missing piece by taking 180 and subtracting 36. All right, so 180 minus 36 gives me 144 degrees. The reason why that's important is because I can now go ahead and use two different vertical angle problems in order to solve for my variables x and y. So since I know that zy minus 100 and 144 are vertical angles, I know that they are equal to each other. All right, so I'm going to say 7y minus 100 is equal to 144, and then I can just go through and solve for my variable y. So we'll do this one first. It's a little bit easier. So let's add 100 to both sides. We get 244, and then let's divide both sides by 7. We get 244 divided by 7 is 34.86. 34.86. So yes, in life, not everything comes out nice and pretty and perfect. 34.86 is a perfectly acceptable answer. All right, and then now I want to solve for x. I know that this top and this bottom angle, those are also vertical angles, so I can set them equal to each other. X squared plus 20 equals 36, and then now I'm just solving for x. When we actually get test time, when we're working on this stuff, we will have a lot of quadratics. So it's really important that we know how to factor. So we're going to be practicing that in class a little bit. So in order to get x by itself, in order to get rid of a squared, we do the inverse, which is square root. That'll cancel that guy out. We know the square root of 16 is plus or minus 4. And then that's going to be my answer. Usually in geometry, we take just the positive values here because we usually talk about distance. So x in this case equals 4. All right, guys, make sure you click on the homework link below this video. Make sure you submit that homework, and make sure you guys are taking good notes. Like, you don't necessarily have to print this out, but just make sure you're jotting this down on a separate sheet of paper as you follow along with the video, just because we're going to be able to practice a lot of these examples. And if you come to class without any notes, you might be a little bit behind your classmates. So, all right, guys, have a great day.